How's everybody doing out there? Hello! Calculus! Yes, calculus. To boldly go, I don't know. Anybody know what show that's from? Probably do know. Yeah, calculus. We're here for the AP calculus exam, which is in how many days? 75 days! 75. 25 times 3, 15 times 5. 75 times 1. 37 and a half times 2. I'm a math teacher. Can't mess with me. 18 and 3/4 times 4. 75 days. Bring it on. Bring it on. I can do division and multiplication. Hey, and don't forget this Saturday, yes, this Saturday at Townview High School will be a calculus review session of the finest kind. Close encounters of the finest kind. Anyway, I understand we have a caller. Hello? Hey, we got, do we need to move the camera up? We got my microphone.
Hello?
Hello? Hey, you guys can see everything that's in front of me, right? Never mind.
What?
What?
Yeah.
Hi. Here's
Hi.
the bell. Here's my stuff. You're going to see me scramble around. What's your name?
Sochi.
Sochi! With an X.
Jaguar.
Jaguar. Hey, Sochi,
Huh?
you going to come on Saturday?
Yeah.
Yeah, you excited?
Haha.
Hey, there's calculators to be given away. I know. You going to win?
Huh?
You going to win?
Yes.
Hey, maybe, if we don't tell anybody, maybe we can, try to fix it.
Okay.
I'm just kidding. Now if you win, no one will believe us. But Sochi, as I look for your picture, as you can see, I'm scrambling around the desk here. Let's go to this problem right here.
Oh my God.
Is that Miss? Hey, tell Miss Kim that she is not allowed to talk during my thing.
Do I take the derivative or? Okay.
Well, you tell me. This is the problem. What is it? What does this equal? Sochi!
Do I take the derivative?
I don't know. Okay, so is that what you want to do first?
Yeah.
Why do we want to do that first?
To do the integration.
Well, but why do you want to take the derivative first?
Because it's inside the bracket.
Because we do always do parentheses first inside the bracket. So what's the derivative of that? That's pretty easy. What's that?
6t
Yep.
plus 2.
6t plus 2. Yeah, that's we could do that. Now, how do you what do you integrate there? What do you do there?
Bump it up and divide.
Bump it up and divide, baby. Bump it up and divide.
6t squared over 2.
Right. So it's 3t squared plus 2t.
And plug it in the 4. 3 quantity.
So you
3
got
times 16.
48 plus 8
Minus 12.
plus 4, right? So I got 56 minus 16. I got 40.
Okay, thank you.
Hey, no, wait, don't go away. No, Sochi, thank you. But Sochi, first of all, who is this guy?
Miguel.
Is that your man?
Yes,
Hey.
he is.
Okay. Hey, Sochi, you know what's something interesting? You know how we plugged in 4 into 3t squared plus 2t? And, we actually, when you take the derivative and integral, you could actually just plugged in 4 into this and subtract 2 into this. It would have given you the same answer.
Oh.
Because it's sort of like, when you take the derivative and then integral, it's sort of like multiplying and dividing. You get back to where you started.
Oh.
Just minus the constant.
That's
Pretty cool, isn't it? Sochi, you know what?
Din.
Hey, call in again, okay?
Okay.
Okay, thank you.
Bye.
Bye. That is, now that was someone nice, wasn't it? Hello? Rebecca, are you hanging up on people again? Hello?
Hello?
Is this Bill?
Yeah, this is Bill.
See all these pictures I got? Can you see this?
Yeah,
Yeah.
See, I know usually the camera's a little higher and you don't see me messing around with this, but the I got 5,000 pictures here. We're trying to.
I see.
But I know we had to cut half of yours out.
Yeah. That was my request actually. So.
That was your request.
Yeah, I understand.
Hey, you want a pretty hard problem? Okay,
Sure.
You got it. Here
Why
you
not?
go. Here you go. Let's do this while I find the half a picture. Go, Bill, go! Okay, can you read all that?
Yeah.
Okay, the line tangent to this curve at the point 1E intersects both axes. Find the area of the triangle. So what do you want? If you want to find the area of a triangle, you want to find the area of a triangle that intersects the coordinate axes. So what do we need to, like if I told you to find the area of this triangle right here.
You would need the y and x intercepts of the line.
Right, and in order to find the y and x intercepts of the line, what would we need?
The formula for the equation for the line itself.
Equation for the line itself. Bill. Excellent, Bill. Excellent. That is a great job.
Thank you.
Okay,
so if it's tangent to the point at one.
Great job. Okay.
It's tangent to the point at 1, comma e.
So 1e. I'm trying to joke around,
So,
and you're doing real stuff here. Okay. So 1e, it's tangent. So, hey, let me ask you something. At x equals 0, what is the value on the curve? At x equals 0.
At x equals 0, it's e squared.
Right, so it's somewhere around like 8 or 9. So the curve looks something like this. Hopefully you'll be able to see that as you plug in more values, you get e to a negative number, which would be 1 over e. So we're talking about this area right here. This is the point 1e. So we're looking for, we need this point and this point, right?
Yeah.
So we're trying to find the equation line. Bill, you're doing great. So what do we do from here?
Okay, so let's see. First, you want to take the derivative of your original equation.
And what is that?
E to the 2 minus x times negative 1.
Okay, excellent. So at the point 1e, what's the slope?
So you plug in 1 for x, and so you have negative e.
Negative e is the slope. Okay, so what's the equation of the line?
So it's y minus e equals negative e times the quantity x minus 1.
Hey, that's a great job. Okay, so, now what do I
so
do?
to find the x-intercept, you set y to equal to 0.
Okay. So to find the x-intercept, find this point, we're going to set y equals 0. So we have negative e is equal to negative ex plus e.
Okay, and so divide both sides by e.
Yeah, I could just
Negative e.
Negative e, okay, 1 is equal to x minus 1. So x is equal to 2, right?
Yes.
Okay. X is,
okay, and so to find the y-intercept, you set x equal to 0.
Okay, so I got y minus e is equal to negative e times negative 1, which would just be e. So we got y is equal to 2e.
Yeah.
Okay, so we got, this is 2e and this is 2. How do I find the area of the triangle?
The area of the triangle is 1/2 base times height.
Right.
So you just have 1/2 times 2 times 2e is 2e.
Hey, that is a great job, Bill. Seriously, fine job. Fine job. But we got sound effects. Hey, Bill, great job. Are you going to be there Saturday?
I'm trying to.
No excuse. The way it's trying to.
Okay, I'll be there.
You better be there.
I'll be there on Saturday.
You better be there. Otherwise, I'm going to put a billboard of that picture with 2 on the everywhere all over the place. Hey, listen, that's a great job. Call in again, okay?
Sure will.
Okay, bye, Bill.
Bye.
Angela!
Yes.
Angela, what's your last name?
Walton.
Angela Walton? How you doing?
I'm fine. How are you?
You remember me?
Yeah.
Of course, I hope. I remember you.
I remember you too.
Okay, now let's not, people are going to start spreading rumors, Angela, okay? Hey, who's your teacher?
Miss Bradford.
Miss Bradford, do I ask her if I have your picture?
Yes.
I do, yeah, there, I see it right there. Hey, how do I fix this? Do I do auto fire or there? Hey! That's a fine-looking picture.
Oh, thank you.
Hey, Angela. Here we go. You ready?
Yes.
A multiple choice question.
Okay.
So it's not, it's not. Pretend this is on the AP exam. Multiple choice.
Okay. Okay, hold on.
Hold on now. Just hold on. Hold your horses.
Okay.
I wonder where they came up with the phrase "hold your horses." Why not hold your dogs?
Okay. B, 0.
Wait a minute. No. How do you know that?
Well, I'm pretty good. I did this all in my head. I just looked at it. And I was like, man, it is so easy. And I just did the whole thing in my head. It was pretty easy.
Angela, okay. Angela, just you and me, babe, all right?
Okay.
What, forget about what you just said. Now, how would you, if this problem's on the AP exam, if you have to take the derivative of a quotient or fraction like that, what do you do?
Take a negative 1 out of the top.
No. That's we're gonna show that later. What would you do normally? What's your first instinct?
The quotient rule.
Yeah, and what is that?
The bottom times the derivative of the top
Ho times d high minus high
times the derivative of the bottom
all over the bottom squared.
squared. Yes.
You still think the answer is 0?
Yes.
Okay. Well, we simplify the top. We got negative x plus 1 minus 1 plus x. Okay, yeah, so this cancels out to 0. And now, for you astute SEM, would you guys have a nickname?
Do we have a nickname?
Like, Hillcrest Panthers and...
No, our mascot is the Eagle, but we just SEM and that's it.
SEM Eagles?
Yeah. But we don't have sports, so...
I know, but you have calculus, so we're gonna call you the SEM Calkies.
Oh, okay.
Okay.
We're cool now.
All right, but Angela.
Huh?
Okay, if we take out a negative 1 out of the bottom, you'd have negative x plus 1,
Plus 1.
which is the same thing as 1 minus x all over what?
1 minus x is gonna be
So
negative
this
1.
simplifies to negative 1, and what's the derivative of negative 1?
0. Oh yeah.
Hey, Angela. There's a guy at Skyline who was asking about you. So.
About me?
Yeah.
Really?
Yeah.
What does he look like?
He looks good. I mean, not that I would know. Hey, Angela, make sure you call in again, okay?
Okay. Bye bye.
Bye. Hello.
Hello?
Who's this?
John.
I got to come up with a hard one. This is John? Okay, I got to come up with a hard one, so I got to think quick here.
No problem.
Okay, let's see here. You ready? If the graph of f of x is equal to, how about 2x squared plus k over x, if that has a point of inflection, we're going to at x equals negative 1, then k equals what? Ha! Go ahead, the great Jean. The great.
First of all, you have to find the second derivative.
All right, so how do I do that?
First of all, find the first one.
Okay, what's the first one?
4x minus k over x squared.
Well, yeah, but why? You're doing that so fast.
Why he's called Jean?
He is called Jean Valjean. You know who Jean Valjean is? It's like from Les Mis. Jean Valjean, something like that. I don't know.
Jean Valjean, yeah.
Yeah. Is that like a French play?
Yeah, Les Misérables.
No.
Misérables, Les Misérables.
Yeah, I'm trying to say something in French, but I don't know how to speak French. Right, this is negative k over x squared, because this is the same thing as kx to negative 1, which is negative kx to negative 2. Okay, that's the first derivative, all right?
Yes.
Je m'appelle Greg. Okay. How's that? Okay.
Oui.
That's right. C. I mean we. Okay, here we go. So what's the second derivative?
4 minus, I think it's plus 2k over x cubed.
Minus plus.
I said plus 2k over x cubed.
You cannot fool Jean Valjean.
Alright.
So because that's negative kx and negative 2, when you take the derivative, you get 2kx and negative 3, right?
Yes.
Okay, and so we got the second derivative. What does that tell us?
Now, you just set it equals to 0 to find a POI.
Okay, so wait, we want to set this equal to 0?
No. You have to find f prime of negative 1 first.
Okay,
Because-
all right, so if we find the second derivative of negative 1, what does that tell us?
Give us the... if we find 0, that means we have a POI at negative 1.
But you told me to find f double prime of negative 1, so what does that tell us? What would that tell? What does this answer tell us? And this answer is easy to do. It's 4 minus 2k. What does that answer tell us? 4 minus 2k. If f double prime of negative 1, what does that mean?
It means the concavity.
The concavity at x equals negative 1. Correct. Excellent. You get a little bell. Okay, and why do we want to set it equal to 0?
Because we know it has a POI.
Right, because at point of inflection, if it has a point of inflection, the second derivative equals 0, possibly. So I mean, in this case, it would equal 0.
Yeah.
So you got 4 is equal to k, and k is
so
equal
equals
to.
to.
Hey, Jean,
Yes, sir.
you don't mind if I call you Jean instead of John, do you?
No problem.
Jean, next time I will stump the great Jean Valjean.
Alright.
Hey, wait, what's a song in Les Mis? I want to sing something. What's a
Which song? In French?
not it? Okay, in French. Like hum a few bars.
Goodbye? You mean?
Oh man, my wife would kill me. She made me see the play, but anyway, okay, we'll figure it out. Jean, I'm gonna get the CD for you.
Alright.
I'll talk to you later. Hey, call in again. Great job.
No problem.
Noreen Napper,
That's me.
how you doing?
Good. How are you?
Fine. Thanks for asking.
Good.
Are you gonna be there Saturday?
Yes, I am. I'm planning on coming.
No, it's this whole non-committal WTY thing. I'm planning on coming.
Well, see, we
Instead
just
of
don't
I will be there.
lie to anybody.
I will be there.
Okay, we're gonna be there.
That's right. I'm planning on coming. You know, it's like, okay, here's a good problem. It's probably too easy for you,
Oh my
but
gosh. Okay.
it's a multiple choice.
Well, first you have to take the derivative of the function.
All right.
So basically, you can rewrite the original function as e to the 2x plus 1 to the 1/2. And
Okay.
then
So
you would,
all right.
Okay, and then power down front, and then subtract 1. I'm sorry.
Why are you sorry?
Because they're telling me to slow down.
No. Don't go as fast as you want. I can hang you with you, Noreen. I can
Okay,
hang.
thank you.
Okay. Times.
Okay, and then so it's gonna be like 1 over 2.
Wait. Are we done here?
Oh, I forgot to say not. Sorry. So it's, let's say, e to the 2. Let's be 2 times e to the 2x.
Times 2e to 2x, right?
Yeah.
Okay. So let's simplify this. How can we make this look prettier?
And the 2's cancel.
Right. Well, you mean the 2 and the 1/2.
Right.
Okay.
Oh.
Remember, we got plug in 0. So how do we want to make it look pretty?
Okay, we can go ahead and plug in 0. We can put the square root at the bottom.
Yeah, that's what I would do too.
Plus 1.
So-
And then put the e to the 2x on top.
So it's e to 2x all over square root of e to 2x plus 1, right?
Yes.
Okay, that's the derivative.
Now we can plug in our 0.
Okay, and what do we get?
And so that's going to be 1 over, I don't know, square root of 2?
1 over square root of 2.
Okay.
So what's the answer?
C. Sorry, I'm just not saying
Why
it.
is it?
It's C.
Why is it C? And please, when you apologize, be more sincere next time. I'm just teasing. Why is how is 1 over square root of 2 equals square root of 2 over 2? Noreen Napper?
Yeah, I'm sorry. I'm having a really hard time hearing you.
Okay, why does this equal that?
Oh, because you can multiply by 1, which is square root of 2 over square root of 2. So you get square root of 2 over 2. Thank you.
Hey, Noreen?
Yes.
No, thank you. And I will see you Saturday.
What? Yes.
Saturday!
Oh, yeah. I'm really having a hard time. Okay.
I know, it's okay, but call it again!
I will. Thank you.
Okay, bye.
Bye. Thanks.
Ronnie Allen!
Hello.
Hello! How are ya?
Oh, can't hear. Hello?
Hello?
Hello, can you hear me? I'm
I
sorry.
can hear you!
Okay, because I'm like...
Ronnie?
Yeah, I'm here. I'm just...
Can you hear me?
Yeah, I can. I'm just...
Have you ever seen Les Mis?
My ears are feeling weird today.
Ronnie, have you ever seen Les Mis?
No, I don't know.
Hey, okay, I might need to call my wife and ask her what the song is on Les Mis here. But go ahead. I'm going to call her while you're doing this problem.
The maximum value of... What? Oh. Okay, you're going to have to take the derivative,
Okay, take the derivative.
which is... 6x squared
Uh-huh. Okay.
minus 18x.
Wait, hold on, Ronnie. Hold on for a second. Hey, honey, we're on the show here. What is a song from Les Mis? Like, sing a few Les Mis. She's choking too. I can't believe it.
He's calling it what?
Well,
Calling his wife.
I'm trying to find out. Okay, now, well, okay. Well, call back when you think of something. Bye.
It's a Broadway bus.
It's a Broadway bus.
Okay.
We have a Broadway bus in this class.
Oh, we have a Broadway bus in this class.
Okay. Well, Ronnie, tell me the.
Okay, you're gonna set it equal to 0 because you need to find the roots of where f prime is equal to 0.
Okay. So how do you do this?
You factor.
Factor. Okay.
Which is minus 3x plus 2.
Wait, what?
It just,
What are you factoring out?
Oh, I took out the 6.
Yeah, I would too.
That's what I do. I mean,
Yeah.
I'm doing it in my head. So I'm gonna factor it to 2x and x. Oh yeah. Okay. And then.
Okay, that's good. That's great.
Okay. And then those are equal to 0 at x equals 2 and x equals 1.
Okay.
And then it's gonna be, now you're gonna put those on a number line. No, not right now. I'm sorry. You're gonna use a table.
I'll use the table.
Yeah, the table makes more.
Okay.
So you're gonna go from, you're gonna put -1 and 2 and 1, because 1 is one of your critical values.
Okay. Excellent. Excellent.
You
So
need your endpoints, and then you're gonna plug these back into F. and
okay.
get
When you plug in 2 into here, what do you get?
2, which is 4, which is 24 minus 18 times 2, which is 36, plus 12, which is 0, I think.
When you plug in 2, I got 16 minus
yeah,
36 is negative 20 plus 24 is 4 minus 1 is 3.
Yeah,
When you plug in 1, the answer is 2 minus 9. That's negative 7 plus 11 is 4. And when you plug in -1, you get negative 2 minus 9 is negative 11. Negative 11 minus 13 is like a lot negative 24. So what's the answer to the question? What is the answer to the question?
4.
Excellent, Ronnie.
Because it's asking for y.
Right,
Y.
it's asking for the value. If it had asked at what point is a critical value occur? It occurs at x equals 1, but the actual value, the maximum value on that interval is 4. That's a great job. You did a lot better job than last time you called in, right, Roddy? You did great, man.
Yeah, my ears are feeling very weird today.
I'm sorry.
My ears.
You know what I hear works real well with for that? Q-tips.
No.
Okay.
I use Proxy.
Okay. Hey, Roddy, call in again, all right?
See ya.
Hello?
Hello?
Who's this?
This is Beulah.
Bueller?
Uh-huh.
What's your last name? Hello?
I'm sorry, what you say?
What's your are you nervous?
Yes.
I am too. Hey, what's your full name?
Beulah McCaney.
Beulah McCaney from Health Magnet?
I'm from Corner.
Oh, they told me it's from Townview. Beulah, how you doing?
I'm sorry, I can't hear you.
I'm sorry about that. How you doing? How about those Cowboys? Carter Cowboys. Carter Cowboys.
Corner Cowboys, yeah.
How's
I'm
Miss?
sorry, I can't hear. They being loud over here.
How's Miss Blackwell doing out over there?
She's doing good. Great.
She's making you work hard, isn't she?
Excuse me?
She's making you work hard, isn't
Oh,
she?
yes, all the time.
You know what? It's going to pay off for you.
I hope so.
Are you going to be there on Saturday?
Yes.
Okay. All right, here. Let's do this problem right here. Carter Cowboys, ladies. Okay, no pressure.
At what point are dx and dx squared both positive? Is it
First of all, if the question is asking when the first derivative and second derivative are both positive, what does that mean? What are we looking for?
okay? If the first derivative is positive, it's increasing, and if the second derivative is positive, it's concave up.
Okay.
Okay. And that would be at B, since it's concave up and it's increasing, and at C.
Okay. Well, okay. It's a B. Does it look like it's increasing? I mean, it is concave up. See, I was trying to get at it. I know it's hard to see, but at B, I don't think it's increasing there. I think it's bottom out. I think that's a min. And like at C, it's concave up, and that's where it changes concavity. So if it changes concavity at C, what would that be called? At point C, it is a what?
Point of inflection.
That's right, a point of inflection. Excellent. At D, it's the same thing. It looks like it's decreasing, but it looks like a point of inflection. But at E, what do we know about what's happening at E?
It's going up and it's concave up.
That's right. It's going up and it's concave up. So therefore, the answer would be E. You see that, Carter Cowboys?
Yes.
Okay. Let me ask you this. How about if at what point is dy dx less than 0 and the second derivative is greater than 0, at what points does that occur?
Less than 0. So it'd be decreasing and concave down. D.
Be D?
D.
Okay.
Out.
D. I got you. What about, what's happening at A?
At A? Oh,
Yeah.
yeah, it's decreasing and it's
It's decreasing, right?
concave up there.
Yeah, it's concave up there, right?
Mm-hmm.
See, at B, it's not decreasing or increasing. It's a min, and it's concave up. At C, it's another it's a point of inflection, and it's increasing. D is a point of inflection, and it's decreasing. So the answer there would be A, right?
Mm-hmm.
Hey, you gonna call in again?
Yes.
All right, please do.
I will.
Carter Cowboys, go Cowboys, baby.
Go Cowboys.
Jared Olds.
Hey, Mr. Fly.
Hey, what's going on? What'd you do in class today? Or
We
yesterday?
didn't have calculus today. We have it tomorrow.
What's the last thing you did?
Took our 6 weeks test.
Oh, the 6 weeks test.
Yeah.
Okay. Well, then let me give you this problem here. Hold on, let me.
Can you hear me?
Use substitution, okay?
Yep. So u equals x squared plus 1.
U equals x squared plus 1.
Du is 2x
Okay.
dx.
Okay.
Are you gonna write it?
Yep.
Thanks. And then in the function you don't have a 2, so you're gonna pretend like there's a 2 in there, so you put a 1/2 out front in front of the
Okay.
integrate sign.
So it's 1/2.
Yes. And then it's u over du.
So it's
Oh.
1/2
yeah.
what?
du over u.
It's 1/2 du over u, right?
Yes.
Okay, which is equal to what?
1/2 natural log of u.
1/2 natural log of u, which is 1/2 natural log of x squared plus 1
Yet.
from 1 to 3. So what do we got there?
Then you plug in 3, and it's
Go, Jared, go! Okay.
I can do it for you.
1/2 natural log of 10 minus 1/2 natural log of 2. Hey, I want to simplify this. How can I simplify this?
put since it's natural log, you could put the 10 on top, the 1/2 natural log of 10 over 1/2 natural log of 2.
Over 1/2 natural log of 2?
Oh, just 10 over 2.
Oh, just 10 over 2?
1/2 natural log of 10 over 2.
Okay.
Yeah.
Okay, so how do we simplify that?
Yeah, 1/2 natural log of 5.
Hey, Jared, do you know any Les Mis songs?
I just watched it last week.
You just watched it?
I can't think. I watched it for my history class.
Okay, well, I'm trying to figure out some songs here. So how can we simplify 1/2 natural log of 5? Go ahead, play.
Take the 1/2, put a square root sign.
Mm-hmm. Yes?
Who are you talking to, me or her?
I'm trying to find out Les Mis. Hey, Homer, I'm going to get you for that one. Go ahead.
Square root of a natural log of 5?
So it's square root of natural log of 5.
Square root of 5, yeah.
Natural log is square root of 5, right? Because it's natural log of 5 to the 1/2, which is natural log of square root of 5, right?
Yep.
Okay. Well, that's a great job.
All right, see you on Saturday.
See you Saturday, man. Bye-bye. Okay.
Hello?
Hello?
Hey, how's it going?
I'm still trying to find out some Les Mis songs. Do you know any Les Mis songs?
Les Mis? Nah, I'm not familiar with that.
Okay, well, let's do a little calculus then instead, all right? Here you go.
Not gonna ask my name?
What's your name?
I'm from W2 White, name is Epsilon. How about you?
What's your last name?
Williams.
Epsilon Williams. How come I don't have a picture of you, Epsilon?
Oh, well, I didn't get it to Miss Harmon yet.
Well, you didn't get it to who?
I didn't get it to Miss Harmon yet.
Okay. All right.
I will.
Okay, I hope so, Epsilon. Are you going to be there on Saturday?
Well, I have a track meet and our Sadie Hawkins dance is that day too, but my first priority is to make it to the AP strategy session.
There you go. Forget about Sadie Hawkins.
And the track. Who cares about it?
What event did you run? What event did you run?
I run the 200 and all the relays.
What's your best time in the 200?
Like a 21.6.
21.6. Are you kidding? That's pretty quick.
Thanks.
Okay, let's do this problem here.
Take the first derivative,
Okay.
which will be negative e to the negative x times 2x plus 2e to the negative x.
Okay. So it's the first times the derivative of the second plus the second times the derivative of the first. Okay, what do we do now? Uh-oh.
Take the second derivative.
Yeah, before we take the second derivative, let's simplify this a little bit.
All right. Well, you can backtrack the e, can't you?
Yeah.
No, factor out the e. Factor out the e.
Okay.
And the 2.
Okay. So what do we get?
And so you get x 1 minus x.
You see that? Okay, if we factor out 2e to the negative x, if you multiply this times this, you'll get this. If you multiply this times this, you'll get that. You
Yeah.
see that? Okay. Okay. So therefore, that's the first. Okay, now what's the second derivative?
It would be the quantity, negative x plus 1 times negative 2e to the negative x plus 2e to the negative x times negative 1. Did you get all that?
I did. I got you covered here.
You aren't on your cell phone again, are you?
No, I'm not. I was trying to find out my Les Mis. I'm trying to find that out. I got busted there, didn't I, with the epsilon?
Yeah, the cameraman kept on putting you on the spot.
I know. His name is Homer.
Don't.
Hey.
Real funny.
Hooray! All right. Okay, this is so. Okay, I think that's what you said. We do first times derivative second plus second times derivative first. I know you guys do it backwards. So this is how do we simplify this?
Well, no, I see 2 e's. Mm-hmm. Well, it would simplify to negative x times 2e to the negative x.
If we factor out a negative 2e to the negative x, what we have left over is this 1 here plus here we got negative x plus 1. So this simplifies to negative 2e to, man, who gave you this problem? This is 2 minus x. Okay, this is a second derivative.
Yes.
So if this is a second derivative, at what point would there be a point of inflection?
Equal to 0? When it's equal to 0.
Okay. And when does this equal 0?
Never.
Never, because e is always e to anything is always positive.
Always positive.
So then when would that equal 0?
2.
Right, but we're not done yet. So we got to make sure that the second derivative changes signs at that point. So therefore, if you plug in like 5, this is always negative because it's a negative number out there. Negative times negative is a positive, and then a negative times a positive is there. So therefore, it's concave down, then concave up. So therefore, x equals 2 is a point of inflection.
Good job.
That wore me out, Epsilon.
You too.
You know, I used to run track when I was in college, believe it or not.
Really?
It's true. I ran the mile, but the 200, 21.6, whew, that's, you know, the world record's 19.32. You know that?
Yeah, I'm dreaming about it.
Okay, well, you keep doing some calculus and you'll learn the limits of your derivatives and you'll be all right. Hey, Epsilon, great job. Call in again, all right?
All right.
All right. Is this Katie Sugar?
No, it's Katie Weiss.
Katie Weiss from Woodrow?
Yes.
Because they just said it was Katie. You know, there's a Katie Sugar there also, right?
Yeah.
Katie, and you could sing, right? I know you can sing.
Not real well.
Well, is there someone there who could sing? Irby can sing.
No, he said no.
Man, Irby is like the musical director of like the Boston Pops.
No, he said no.
Okay, well, Katie, sing for us.
Okay, it's On My Own is a song.
On My Own. Okay, I'm going to call my wife back since she couldn't figure it out. Okay, you don't mind. So, Katie, sing. That's okay.
On my own, standing here beside me, all alone, I'll walk with him till morning.
That's very good. Oh, keep singing.
Without him, I feel his arms around me. And then it's like...
She's not even answering. That's great. That is great.
Okay, Adam's going to work the problem for you.
Adam?
Greenfield.
Oh, I know Adam wants a little inspiration. I mean, he called last week about 5 minutes of 5 1.
Yeah, that's right.
I know. I'm going to get your inspiration for you.
All right. Hey, take it easy on me, man. I got a soccer game tonight, so I need
take it easy? Okay, I'll let's see here. I'll get you something. Let me pull it out here. Excuse me. Take it easy. Okay. Okay, here you go. It's not exactly real easy, but we're gonna get you some inspiration. Adam, this is Adam's request.
All right.
Go, Adam, go. This person, I don't even know. It's just. All right, so Adam.
Yeah.
Wait, hold on. No choking now.
You're putting me on the spot here.
I know. There you go. A little, there you go.
Well, if it's going from going to 0 and the negative, that means it's got a negative slope on the. So it goes. It's a parabola going from through the 0, 0.
That's right. It's a parabola going through 0, 0, right? Now, is it a parabola that looks like this or looks like this?
I don't know what you're.
Since you
yeah,
can't see
drawing
either
anything.
one, how about that? I did draw it. It's just one.
It's the one on the right.
The one on the right,
Yeah.
because we know that the function you were there, Adam. This is way too easy for you.
Yeah,
You're like-
yeah.
yeah.
I told you to take it easy on me.
Okay, but this was not that easy. This is pretty hard. If the derivative is negative, you know the function's decreasing, and if the derivative is positive, you know the function's increasing. But
Yep,
you said it was at 0, 0, right?
Yeah.
So you're saying, is it possible that it could look like this instead?
Well, you'd have to change the. No, it's not possible.
Not possible. Okay. Why?
All right, I lied.
You lied?
Yeah, it is possible.
Why is it possible?
you got to change the slope of the line, right?
Okay, well, we got f prime of x is equal to, I mean, what does that look like?
What do you mean? What does it look like?
I mean, what does this equation look like?
Y equals X.
Yeah, it looks like x, right?
Yeah.
So if that's the case, so f of x would be equal to what? If f prime is x, what is f of x equal
X
to?
squared.
X squared. What's the integral of x?
I can barely hear you, man.
What's the integral of x?
The integral of X is X to the X squared over 2.
Right. Plus c. And that's the whole key, is the plus c.
Gotcha.
Is that it could, because here, this graph and this graph, the slopes are exactly the same, and this is a graph of the slopes. You see that?
Yeah.
We know at x equals 0, the slope is 0, but it could be shifted. It could look like anything.
So the C is where it is on the.
Right, exactly.
Y-axis.
Excellent job.
All
Great
right.
job, Adam. Okay. Hey, make sure you call in again, and next week we'll do other. Thank you, Katie Weiss, for the beautiful rendition of "On My Own."
Yeah, she was happy to do it.
Okay. All right. Hey, great job. Call in again. All right.
I'll call in next week, man.
All right. Are you gonna be there Saturday?
Of course. How can I miss it?
All right. Good job. I'll see you Saturday.
All right.
Hello.
Hello,
Who's this?
Shamika. Jaguar.
What's your last name?
Joe.
Do I have your picture?
Yes, you do. You have a whole bunch of me, really.
I know. I'm just kidding. Quite frankly, there's people who are questioning why I have so many pictures of you. I'm looking for you. I got here late. I got here right before the show started. I didn't have time to organize my pictures. I'll get your picture in a second, okay?
I'm black, so, you know.
You're what?
I'm black. If you needed help to find a picture.
Wow. Okay. I'm white. If you can't see me. Hey, okay, Shamika, I'm going to look for your picture. I look for an African American who goes to Molina. No, I'm just kidding. I know who you are. On my own, standing there beside me.
Please don't.
Okay, sorry. Is that Erica?
Yes, it is.
Erica, you going to be there on Saturday?
Yeah.
All right.
Alright. Are you?
Yes, I am.
You'll finally meet in person.
Okay.
Are you on the phone?
I'm not on the phone. You're on the phone.
You're on the phone.
I was on the phone. And let's see what you did, Homer. Yeah, everyone thinks I'm going to be on the phone now. Come on. How do we do this problem?
Oh, yeah.
Let's see. What you rewrite? Take a derivative.
Okay.
Rewrite it, but you can rewrite it.
Okay, rewrite it. How do you want me to rewrite it?
Quantity 4 plus sine x to the 1/2. Then
Okay.
do the power, break it down, is 1/2. Quantity 4 plus sine x. Quantity times, to the negative 1/2
Times
times cosine.
cosine.
X.
Excellent. Is it positive or negative cosine?
Positive.
Are you sure? Are you positive?
Yes.
Okay.
Disco.
What'd you say?
Disco.
Disco. That's right. Hey, that's I used to say that stuff. Cool. All right. The disco, baby. Disco.
Yeah.
Derivative sine is cosine. Okay, I'm still looking for your picture. Keep going. That's what I'm doing right now, in case you don't believe me.
So you plug in the x value, the 0.012.
Okay. Ooh, are you sure? Okay, let's read this question. It says the approximate value of... Okay, so we have this graph. Like, what's the sine of 0 equal to?
0.
Right, so it's a square root of 4, so at x equals 0, it's 2. So whatever this graph looks like, you know what I mean, and at like pi over 2, it's 1, so it's square root of 3. So whatever it looks like, and we know it's going down, we want to figure out, whatever it does look like, we want to figure out what is this value at 0.12. So what we want to do is we want to figure out the tangent line at x equals 0 and plug 0.12 into the tangent line. It is hard to see. 0.12 in the tangent line to estimate because it's so close to the value on the curve. So what we want to do is find out, we don't want to plug in 0.012, we want to find out the equation of tangent line at x equals 0, then plug in 0.12. So what's the equation of tangent line at x equals 0?
Just plug in a 0.
Right, and if you plug in a 0 into the derivative, what do you get?
0.
I mean,
Slope.
you get the slope, right? Excellent, excellent, excellent. So if you plug in 0 here, I'm still trying to find your picture. You know, I don't think I like this game here. All right, so if you plug in 0, what do you get?
You get
How do we simplify this?
put it over 1. I mean, I don't know.
Put it over.
1 over. Yeah. Wait. 4 plus sin x. Yeah.
Okay. Times cosine x, right? Okay, if that's the case, when you plug in 0, what's the cosine of 0 equal to?
1.
Cosine of 0 is 1, right?
Yeah.
So it's going to be 1 over 2 times square root of 4.
4.
So the slope is 1/4, okay? So if the slope is 1/4, what does that tell us?
Don't you have to find a point? Don't you have to find a point or something?
That's right. And so how do we do that?
Plug in the 0.
Plug in the 0. Excellent. So if you plug in 0, what do you get into the function?
2.
Right. It's 0, 2. So you got 0.02 and a slope of 1/4. So the equation line is y minus 2 is equal 1/4 times x minus 0. So it's y is equal 1/4 x plus 2. And now it's a lot easier, like if you did not have a calculator, this is what they used to do in the olden days. Like if you wanted to estimate a real good, like what's the sine of 0.012, well, it's hard to figure out the sine. You can't really do it. It's really hard. But you could get really close by plugging in 0.012 into here, because all you have to do is multiply like 0.25 times 0.012, and then you would get the estimate of the on the line. Ms. Brzezinski will do a better job explaining it to you. All right?
Okay.
I'm still looking for your picture, as you can see. I can't find it. Oh, there it is! Shamika J!
Yay, that's me! Woo, senior!
Hooray! Hey, great job, Shamika, okay?
Okay.
Make sure you call in again, all right?
All right. Bye.
Chiffon?
Hi.
Hi.
Do you remember me? I'm Noah's cousin.
What's your last
Noah
name?
Bailey?
Noah Bailey?
Yeah.
Well, what's Noah doing?
He's still going to college and he's playing with his band a lot and stuff.
Where is he, where's he going to school?
UT.
UT. I know his PSAT score.
Yes, I remember. You told me last year.
I did? I still remember his PSAT score. And where did you go? Did you go to Long Middle School?
No, I went to Dallas Environmental Science Academy.
Very interesting. So who's your calculus teacher?
Miss Bradford.
Miss Bradford. And what's your last name?
Bailey.
Oh, same last name. Do I have your picture?
You do. You don't have to show it, but you do.
Of course I do. Okay. Well, let me give you a problem here. Are you nervous?
Sure, why not?
See, usually, usually this stuff is like covered, so you guys, everybody's seen what I do here. I'm just like desperately, as I'm talking, I'm desperately trying to look for a problem and look for your picture at the same time, and that's what I do half the time. But not that anybody really cares.
I was trying to call in earlier because I'm a Broadway buff and I was trying to remember that Les Mis thing.
Hey, do you know another song?
Not from Les Mis.
On my own, standing there beside me.
What are you doing in Dallas? You should be in New York City.
Yeah, New York City. All right, here, let's do this problem here. I'm gonna find your picture as you're talking. I have to multitask.
Okay.
All right, here we go. Here we go.
Oh.
What do you think? What do you think?
Okay, well, the graph is f double prime of x, and it
Right.
wants where f prime has a point of inflection.
Point of inflection, right?
And,
This is not that easy, is it?
alright, so to get the point of inflection, you'd want f triple prime, so where that would equal 0, so it's where f double prime has the maximum and a minimum. Which
Very
is at
good.
-2 and 0.
Right, boy, that is excellent. I do not have your picture.
You don't? You're supposed to. I posed for the camera.
I'm
you
looking.
Push the button.
I'm looking. I'm trying. I'll find it. As you can see, I'm looking. Right, because when f double prime is equal to if it equals 0, we know that f triple prime changes from positive to negative here, right? Here it changes. F triple prime changes from negative to positive. So if f triple prime changes signs, f prime has to have a point of inflection, right?
Right.
That is a fine job, Miss Bailey.
Thank you.
Fine job. You're going to have to call in again until see, next week I'll have the pictures organized if I get here on time. And do you know who you're standing next to? Or actually, you wouldn't know that. I'll find it next time.
Okay.
Okay. But call in again, all right?
All right.
All right, bye. Ashley?
Yes.
Carter Cowboys?
Yes.
Hey. Whoa, who is that?
Beulah.
Beulah?
Yeah.
Hey, are you going to be there on Saturday?
Yes.
I sense some hesitation there. I sense some hesitation now, Ashley. You're gonna be there Saturday. This is a real key thing for y'all to be there. You know, we're giving away.
Hold up, I can't see it.
You can't see? All right.
Yeah.
Here, let me make these bigger.
5 to 3, so you add them together. Oh, I'm sorry. Oh, you flip.
Okay. Talk to me now. Talk to me. Can you see that?
Yes, I can see it. Add them together.
Okay. It's all right. This is a pretty hard problem. Hey, let me ask you something. What is the integral from 3 to 5, just in general?
3 to 5.
3 to if
it'll
it
be
wait, hold on. I mean,
-4.
right, but from 3 to 5 to 5 to 8, in general, what does that equal?
From 3 to 5 and 5 to 8, what do they equal?
Right. No, I'm sorry. What is this?
3 to 8.
It equals, excellent, 3 to 8. Is that what you said?
Uh-huh.
Okay, I'm sorry. I was still trying to find pictures. Okay. So we know that this, now, so therefore, let's find, always try to have it set up like this. So what's the integral from 3 to 5? You already told me it's -4.
Uh-huh.
What's the integral from 5 to 8 equal to?
-2.
So what's the integral from 3 to 8?
That'd be -6.
So what's the integral from 8 to 3?
+6.
Excellent. That's great. You and Beulah, you guys stop by and say hi on Saturday, right?
Okay.
Carter Cowboys.
All right.
All right, call in again. Who's this?
Help.
Hep?
Yes.
What's going on?
Not bad.
Not bad?
No.
Okay. Not bad at all, huh?
Yes.
What's Miss Harmon serving out there today?
Cookie and chip.
Cookies and chips?
Yes.
Okay. What type of problem do you want? I can't find one, so.
Anyone you can find.
Anyone I could find? Okay. Here you go. How's that? We'll find that one.
Okay. First, we need to draw that graph.
Okay. How do you do that?
It's the absolute value, so 2 to the right.
Okay. 2 to the right. Excellent. Excellent.
Then we plug 0 into x, so we got 2.
Okay.
So that's going to be 2y.
Okay. So 2 there. Is that what you said? Okay. So x is 0, y is 2.
And we plug 6 in, we get 4.
Excellent. So let's just draw it like this, right? Excellent. 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 Hep. Okay. So we really just want to find the area of these two triangles, right?
Yes.
Okay. And then what is that answer?
Using 1/2 times base and height.
1/2 times base times height. So what's the answer to the little triangle?
The little triangle is 2, and the big one is 4. Wait. It's 6, because 4, yeah.
It's what?
It's 6.
This
What?
is 4 and this is 4, so it's 1/2 times 4 times 4, so it's 8. So the answer would be 10.
Yes.
Right, Hep?
Mm-hmm.
Hey, great. You see that?
Yes.
Okay. Hey, listen, Hep, great job. You going to be there on Saturday?
Absolutely.
You got it. All right, we'll see you Saturday.
I see you then. Thanks.
Lacey! Is this Lacey, what's your last name?
Steven?
Lacey Stevens. Oh, I know Lacey Stevens.
Yeah, from PSAT program.
You go to
Brian Adams.
you go to the same type of service as Michael does. Do you know who Michael is?
No.
Michael Bell? He's an elder at the church you go to.
Oh, yeah.
He runs this program. He runs the show.
Really?
Yeah.
Hi, Mike.
Hey, Lacey,
Yes.
how you doing?
Great.
Are you nervous?
Yes.
Are you nervous?
Yeah.
Okay. Well, we got like 1 minute left, so
Okay, give me an easy one.
I have to because we only have a minute left.
Okay.
I have to think of something quick. Okay, here we go. How about this? How about the integral of x cosine of x squared? I just was told that you're a youth elder. Very good. Okay.
Yes, I am.
Go ahead, Lacey. How do we do that?
U substitution.
U substitution. Excellent. Okay.
X squared is u,
Excellent. Excellent.
and du is 2x dx.
Okay.
So you're integrating cosine of u du.
Right, and it's 1/2.
Right.
Right. Okay. Excellent. What's the integral of cosine?
Whose derivative is cosine? Sine.
Excellent. Hey, I like the way you did that. Whose derivative is cosine? It is sine. That is a fine job, Lacey Stevens. That is really good.
Thank you.
That's a great way to think about it, and so that would be the answer, right?
Yes.
Hey, Lacey?
Yes.
That really is very good. That is a great thought process there.
Thank
All right.
you.
Hey, you going to be there Saturday?
Yes.
All right, we'll see you then.
Okay.
Y'all, hey, see everybody on Saturday, and be careful. See you Saturday. Good luck. Bye.